the concept of signal subject is required in other subjects also, like control systems or circuit networks or power systems. So on those subjects also, the concept of these signal systems is required. So first of all, we should know what is called signals. Okay, the signals, it can be defined as that something which carries some message. Okay, a message or something informations, that is called signals. Like if somebody talking, like I am talking, so you are listening, so I am delivering some message, so this voice also one kind of signals. Like if some video we are watching, then that video also one kind of signals. Okay, if when you're going in a road, then at the side some pictures or turn left, turn right symbols are there. Okay, those symbols are also have one kind of signals. So there are different types of signals. So first of all, we should know the definition. Okay, what is called signals? It is a physical quantity. It is a physical quantity that convey or that carry some information or message, some information so it is a physical quantity that convey information or message about some physical phenomenon. Like as I said, like example is like audio signal, like video signal. Okay, so signal is nothing but which convey some message or information, etc. So we can earlier we write in like xt equal to sine omega t. We know this term. Okay, sine omega t. We had it in a class 12 or class 10. So sine omega t, here you can see that this is a function kind of things. Okay, where you can see that this t as a variable, we know this is independent variable. So what happened when this function or the signals depends on only one types of independent variable, then that is called a one-dimensional signal. So if a signal, you can write the definition like that. If a signal depends on one independent variables, then those signals are called one-dimensional signals. And for second, you can write that when or if a signals depends on two independent variables, then those signals are called two-dimensional signals. So the signals may depends on multiple independent variables also, like 3, 4, or up to n. If it is depend on n number of variables, then those are called n-dimensional signal. Okay, so this is all about the signals. So we also know. So there are also, we should know how to represent the signal or how to write a signals. Okay, we know that we already said. Next is representation of signal. Representation of signal means, first of all, the signals are basically two types. Basically two types. One is continuous signal, another is discrete time signal. Okay. So continuous time signal means it's present for every instant of time. Means if you take any signal, like if this is a signal, okay, in this signal you can see that the amplitude values is exist or it's present for every instant of time. Every instant of time means if t equal to 1, then also we have some amplitude values. If t equal to 1.001, then also we have amplitude values. If t equal to 1.00001, then also we have amplitude values. Means it presents, it has, it exists for every instant of time. Then this is called a continuous time signal. And discrete time signals, the signal exists for some discrete set of time. This should be straight, okay. So here you can see this axis is represented by time, okay, t. Here discrete time, this axis is represented by n. So here n means integer value, n equal to 0. Here this is 1, n equal to 1, this is n equal to 2, n equal to 3. Like that it's go on. And for every, somebody send request. Okay. So for every instant of time, for some set of times, we have some amplitude values. So this is called a discrete time signals. Okay. So we can define it like that. Okay, the continuous time signal has amplitude values for every instant of time, whereas discrete time signal has value for some set of for some discrete set of time. Okay, so here we can say this is nothing but, you can say that okay, this is xt. Then we can say that this is a step from 0, so it is sine wave. So xt equal to sine omega, you can write. So you can see that we can represent the signal by this waveform. This waveform also we can write by writing the function. Also we can represent the signals. So represent the continuous time signal can be represented by two ways. One is graphical representation. And another is functional representation. So graphical means if we showing some plot, plot like this. This is one type of graphical representation. Okay, functional representation means, like I said, that xt equal to sine omega t. This is a functional representation. Similarly, discrete time signal can be represented in 4 ways. First one is graphical representation. Second one, graphical. This is one kind of example of graphical representation. Second one is functional representation. Functional representation, like here I say that this time axis would be represented by n. So the t replaced by n, so it will be xn equal to sine omega n, where n is the value 1, like 1, 2, 3, 4, 5, 6, like that. Like third number is tabular representation. Okay, tabular representation means they show the every values for every instant of time. Means it is like that tabular form. We write like n here. Here we write xn. Okay, for tabular form we should the n like 0, 1, 2, 3, 4, or like that -1, -2 also may be there. So for n equal to what is the value? If value is 1, if n equal to n equal to 1, what is the value? Absolute value here we have to put like here 2, here 3, like again 2, like again 1, like that it goes. So and last one is sequence representation. Sequence representation is very important. So sequence representation also have two types. One is finite duration sequence. Finite duration sequence means if and it is given by like 2, 3, 4, 5, like 2, 1. This is the values of amplitude values of the signal is given. Okay, like here we don't know here the values of n is not given. We cannot say what is the value of n, but to represent that some arrow mark is given. Like here, if arrow is given like that, this is should be x of n. Okay, x of n. This for n equal to this is if arrow mark is here, then this is for n equal to 0, and this is for n equal to 1, -1. This is for n equal to 1, this 2, 3, 4, like that. If xn equal to is given 5, 1, 2, 3, 2, 3, 1, like that, then this is 1. If arrow mark is given here, then this is for n equal to 0, and this is for n equal to -1, this is for n equal to -2, this is n equal to -3, this is n equal to -4, this is n equal to -5. The representation, if we try to plot, then this would be 1, 3, 2, 2, 1, 5. Okay, this is for n equal to 0. You have write like this: 0. This is 1. This is 2. -1. This is -2, -3, -4, -5. And also you can show the amplitude also here: 1, 3, 2, 2, 1. This 5. The amplitude may be -5. If -5, then we have to show in the below side of the x-axis or the time axis. So another example, let me give. Sometimes in the questions, the values will be like that, like 2, 1, 0, 2, 3, 4, like that. If there is no arrow is given, then by default we have to think that this 2 is nothing for n equal to 0, and this is for n equal to 1, this is for n equal to 2, this is for n equal to 3, 4, 5, like this. Okay. So these are all falls in finite duration. Finite duration means there we can count how many samples are there. Here we can how many elements or samples is there. Here you can say there is 6 samples or 6 elements or 6 amplitude values is there. Like that, there are other kind of sequences there. Second types of sequence is infinite duration sequence. So infinite duration sequence means if xn is given, xn equal to 2, 3, 2, 1, 3, 4, and there are infinite sample of values, infinite amplitude values is there, then this is falls on under infinite duration signal. So signal may be plot like this. For plotting, if some arrow mark is given here, like this is arrow mark is given, so at 0, like 2, amplitude is 2, okay, here amplitude is 3, again 2, 1, 3, 4, 3 and 4, okay. Like this, you have to show the dot mark at the right side and left side also to show that this is the signal for infinite duration sequence. Okay. So these are all these all are from different types of representation. Okay. These are all are from the different types of representation of the signals. So so now we have to know about what types of signals are there. What are the different types of signals are there? Okay, as we already know, sine wave, cos wave, whether there is all total 15 or 16 different types of signals are there, and we should know all the signals by its plot and the functional representation also, mathematical representation of those signals also. So let's start from initial one. All these signals, what we what I am going to teach now, all are fall in elementary signals. So elementary signals means these are basic signals, or you can say these are standard signals, and we should know the formulas or graph also. Elementary signals. So elementary signal, first elementary signal is unit step signal. This is the first kind of signals. Okay? Unit step signals. So unit step signal defined. It is defined as how ut. The unit step signal is represented by ut. Okay, ut equal to 1 for t greater than or equal to 0, and 0 for t less than 0. This is the functional representation, you can say, and you should remember these equations, these functions. Then ut means unit step signal. Ut equal to 1 for t greater than or equal to 0, or 0 for t less than or equal to 0. So we should know again graphical representation of also. Graphical representation. Graphical representation is given like if this x-axis represented by t, and this, if that is ut, then you can see that the positive values of t, the amplitude is 1. So will gives a constant amplitude for all the values of t, positive values of t. So this is amplitude is 1. Okay, this is you can say this is a unit step signal. If amplitude is a or like a 2, 3, 4, any kind of values, then those signals are not unit step signals, but you can say them as step signals. When the amplitude is 1, then those signals is called the unit step signals. So you can say that this that any signal which amplitude is constant and its fall on its exist for only for the positive values, so signals falls on step signals. Okay, like another elementary signal is ramp signals. Those signals are very important, and you should know the functions and this plot also. Unit RAM signals. Unit RAM signals are defined, or it is defined as RT. Unit step signal represented by RT. Okay? RT equal to T when T greater than or equal to 0, and 0 when T less than 0. Okay. This is the representation here 1, but for unit time signal here T will be there. So graphically, how we can plot? Graphical representation. Graphical representation would be like this. For every positive values, if we increase the value of T, then we'll have the same values. Means it's like a slope, like this. It will goes on xt. So you can see that if T equal to 2, then value also 2, like 3, 3, like that. If we increase the time, the curve will also increase linearly. Okay, but for negative values of T, there will be no amplitude values. So this is one kind of RAM signal. But you can see that here unit step signal, I have said that when the amplitude is 1, then when the amplitude is 1, we can say that this is the step signal. Okay, but here we cannot say that okay, there is an amplitude one or not. But I have said that but this is a RAM signal, unit RAM signal. Why its name has come as unit? Okay, that's also we should know. Here I said that if since its amplitude is 1, that's why it's come as unit step signal. Here unit RAM signal, why is called unit RAM? Because this slope, okay, slope means the inclination. Okay, this slope is nothing but is unity, or you can say slope is 1. Since slope is 1, that's why this is called a unit RAM signal. When this slope will be 1, the slope will be 1 when there is an angle of 45 degree. Okay. So is it whether this doubt is clear? Anybody has any questions?
No, sir.
It's clear, no? The writing and this voice also all are clear.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Come to the then next point. I have explained this unit step signal and unit ramp signal. Okay. There are one important note is there. Important note is there means I have seen that unit step signal and unit impulse signals. So important relation is that we can get a ramp signal from unit step signal. Also, we can say we can get unit step signal from ramp signal. How we can get using the help of integrator or differentiator. Integrate of the unit step signal is give nothing but ramp signal. Okay, that you should remember this note. Integrating the unit step signal gives the ramp signal, or vice versa, or you can say conversely, the unit step signal can be get by differentiating RAM signal. Somebody sending message to join. Still two people are sending. Okay. Tell everybody to join early in the class. Okay. Within 10 minutes they should join in the class. So what I have given, that's there is important relation between this unity step signal and RAM signal. If we integrate a unity step signal, we will get the RAM signal. How? That give the derivations like the mathematical steps. When we integrate a unity step signal, okay, dt, okay. Forget about the limits. It's maybe minus infinity to t if or tau like that. Forget about the limit. Yeah, I have said that unity step signal is nothing but, if this is a unity step signal, is nothing but 1. Okay, then this we should put 1 here. Then dt, this will give what? Output would be? Can anybody say?
Yes, sir.
T. So you can see that when we integrate the unity step signal, we will get the T. Conversely, what we will see when we differentiate the RAM signal, differentiate d by dt, we get T. Okay, RAM signal means this is nothing but T, or we can write like this also. RT equal to d by dt, so RT equal to T. So d by dt, T would be what we say? We can say that is 1. So we will get 1. 1 means you can say this is a unity step signal. Okay. So like that, mathematically also we can, our concept may be cleared. Okay. So just writing or memorizing the things, we cannot clear our concept. So we should know the mathematical behind of those concepts also. Now in signal systems, in the subjects, okay, mathematical derivation also required, but the visualization or the waveform also we should know. So in any questions or anywhere, if something waveform is given like that, okay. Okay, something middle, this part is something transformation is here, some mathematical operator will be here, that is not visible. So they may they may ask the question, okay, how will get this step signal or this type sort of signal in time in this inclination form? How? So our question will be by integrator. Understood? If we integrate this signal, we'll get this waveform. So this concept should be clear. Okay. So like that, if we plot this signal at the left side and this signal at the right side, then we should have we should use the differentiator. So this is the operation part of the signal. Okay, we should know the waveform also. Okay, what integrator do, what differentiator do. So like that, behind you should visualize the things. So we have discussed two elementary signal till now. One is unity step signal, another is unit ramp signal. Third one is let it be parabolic signal. Parabolic signal is defined as Pt equal to t square by 2 when t greater than or equal to 0, and 0 when t less than 0. Okay, and graphical representation of parabolic signal is graphical representation would be like this. This is PT, this is T. Okay. So there is one relation between unit ramp signal or unit step signal here. If we integrate ramp signal, okay, will give nothing but a parabolic signal. If we double integrate, unit step signal, here unit will be there. Unit step signal, then also it will give parabolic signal. How it is so? When you double integrate ut, dt, dt, okay. First, this part will give the ramp signal, rt, dt, okay. RT is nothing but t. This is dt. So by integrating this part, we will find t square by 2, like that. So when we double integrate a unit step signal, we will find the parabolic signal. When we one time integrate the ramp signal, then we'll get the parabolic signal. So like that, you should know the relation between each of the signals. Come to the 4 types of signals. This is called unit impulse signal. This signal is very important. The impulse means some spikes on the x-axis. The amplitude is exists for a little time, for a very short duration of time. The spike will be there in the signal. So it is defined as del t equal to infinity when t equal to 0 and 0 when t not equal to 0. Okay. So graphical representation also we should know, and graphical representation will give us the visualization concept. This graphical representation will be, if this is time axis or axis represented by time, and y axis will be this. This arrow mark will show that the amplitude is going to be infinity at t equal to 0. At t equal to 0, we have the amplitude as infinity, and other values of t, there will be no amplitude or no signal presence. So this is a impulse signal. So some property or note is can be written like this. Area under unit step signal is unity. That is the very important property. Area under unit impulse signals is unity. Unity means 1. So we can write like this also mathematically. That's minus infinity to infinity del of t dt equal to 1. Okay. So area under the infinity. So you can see that we know that this integration of any signal gives the area enclosed by those signals. So integration nothing but it gives some area of a signal. So from lower limit to upper limit, if this limit shows the existence of the signals. So second note you can say that, or another thing is that, okay, we can say that impulse signals is nothing but a limiting case of a rectangular pulse. Okay, we can say what I am saying, that therefore since the area is 1, therefore we can say that impulse signals is a limiting case of a rectangular pulse signal. Okay, how, what do you mean by this sentence? Okay, let me give visualization of this concept. This is one kind of rectangular plot. Okay, if this signal exists for delta time and this, okay, delta time, I am saying that the area under of this curve should be 1. So this is 1 by delta. Okay, so area of this rectangle is nothing but height into breadth. So 1 by delta into delta will give nothing but 1. So this is the limiting case. Why is limiting? Let me give. Let me say. So if we increase this, if we decrease the duration of this delta, if we delta carry, if it decrease, means if this pulse is thinner in their, somebody is still giving the request for joining the class. Okay, so if we decrease the delta, the duration of the delta, if we thinner this width, then this amplitude will be increased, because our aim to keep constant of the area. Okay, when delta tends to 0, means delta tends to 0 means if we keep this width or decrease this width, then amplitude will be increased. So ut minus u t minus delta, this is the this is the representation of this signal. How it is, let me give little idea. It will clear after when we go to see this operation on the signal. This is the delayed version of the signals. Okay, this is unity step signal. We know this is unity step signal. Okay, and this is a delayed version of the signal. Means it's this is represented by u. If it is delta, it is represented by u t minus delta. Okay, when you subtract this signal, I am subtracting here. No, when you subtract this signal, we will find only this part. Only this part. This part is nothing but this pulse signals. When you subtract this, these two signals, we will get delta signal, 1 by delta signal. Okay, amplitude is 1 by delta, then this signal will be present. So that's why it is said that it is a limiting case of the rectangular pulse signal. Limiting case means when we decrease this width. Okay, when you decrease this width, this amplitude will be increases, because our aim to keep the area enclosed by the signal should be 1. When this delta is approx to 0, then 1 by 0 means what? Infinity. That's why it is called a limiting case of rectangular pulse. Okay.